This tutorial is on basic ventilator graphics as shown through the 840 Puritan Bennett ventilator. On most ventilators, the common scalars that can be selected are pressure versus time, volume versus time, or flow versus time. This particular picture is showing the selection of a pressure versus time scalar. You can note that the time is located on the horizontal axis versus the pressure is located on the vertical axis. An arrow also shows to where the therapist can touch for the plot setup and select what type of scalars they would like displayed versus what type of loop they may want displayed. What's also being pointed out in this particular photo is the fact that the patient is receiving PEEP. You can see that the pressure does not return to a zero baseline, but is instead elevated to a 5 centimeter of water baseline pressure, which is the PEEP that the patient is receiving from the ventilator. The two common loops that can be displayed are a pressure versus volume loop and a flow versus volume loop. This particular picture shows a pressure volume loop. You can see the pressure on the horizontal axis, and you can see the volume on the vertical axis that is being displayed. On this particular ventilator, only one loop can be displayed at a time. Again, this repeats that two scalars could be displayed at the same time. This particular setup shows a pressure and time scalar versus a flow and time scalar, or the one loop can be viewed at a time. In this setup, you can see that the plot was chosen as a pressure volume loop. Again, showing the pressure on the horizontal axis and the volume on the vertical axis. Note on the front panel where the graphics can actually be selected. You can see the picture of the graphs on the bottom of the upper screen. This shows two of the three possible scalars that can be displayed for the plot setup. Plot 1 is showing pressure versus time, while plot 2 is showing flow versus time. The scales can be changed for better viewing. You can either change the time set, or in this example there was also a volume time scalar. The volume scale could be changed as well. When looking at the flow time scalar, one can easily discern if the decelerated or the ramp waveform was the chosen waveform pattern versus if the square or constant waveform pattern was chosen, again by simply looking at the flow time scalar. Another advantage of looking at the loops, in this case the pressure volume loop, is an easy way to discern over distension. In this example, you can see that there is a bit of over distension because it's taking a high pressure to deliver that tidal volume to the patient. Air trapping is yet another issue that can easily be displayed. Air trapping is easy to detect on the flow time scalar. You can also look at the different graphics and scalars to determine what the set parameters are. In this example, it is showing on the flow time scalar that the set flow rate is 50 liters per minute. On these two scalars, we're looking specifically at the volume time scalar to note that a leak is now present. The circle will point out where you see a huge drop or a quick drop in the volume delivered due to a leak being present. So it's easy to view issues that arise such as leaks, air trapping, or over distension simply by using your graphic display. It's also quite easy to view graphics or waveforms from a distance, say as you're walking through the unit passing by patients' rooms who are on ventilators. You can easily look in and look at the graphic from a distance much more readily than some of the numbers that are displayed. This particular graphic is showing a pressure time scalar and a volume time scalar. We can easily see just by looking at the volume time scalar that the set tidal volume is 500 ml. We can also see that the pressure required to deliver that 500 ml is approximately 38 centimeters of water pressure. This concludes the tutorial.